delegates and participants from various academic institutes, research institutes, and various industries. So I am Dr. Hemant, working as Associate Professor in the Department of Mechanical Engineering. So I take a privilege in welcoming you all for the day STTP program, our STTP program on automation technologies in FMCG sector in collaboration with MSME Development Institute. So today we have the eminent speaker with a combination of academics background, research, and industry who will be delivering the topic on automation in grain and food processing industries. So we have the speaker with us, Professor Srinivas Ye. So is the senior principal scientist and former head of the department of grain science and technology, working in Central Food Technological Research Institute, Mysuru, which is the constituent lab of CSIR, Council of Scientific and Industrial Research, New Delhi, which came into existence in 1950. So he did his mechanical engineering graduation in NIE and passed out in 1984. Then he pursued his Master of Engineering in Management. So soon after his educational career, he moved on to the professional career. Like he started his career with as a lecturer in lecturer for mechanical engineering department in NIE. Then during 87, he was working in the Kirloskar Systems Limited as a graduate trainee. So from 87 to 92, he worked as a research trainee in CFTRI in the Department of Serial Science and Technology. From 92 onwards, he started working as a scientist in the Department of Grain Science and Technology, CFTRI, Mysuru. So this is about his educational career and professional career. So during this career, professional career, he has very good achievements. So as a research engineering trainee at CFTRI, so the central government of India established around 10 regional extension service center for rice milling units in different states across the country, right? So there Professor Srinivas was given a task of information dissemination to all the interested persons in their vernacular language, planning and conducting one-day workshops across the state in different districts, then conducting demonstrations of improved rice milling methods and publishing of booklets apart from the assistance to the scientist in day-to-day R&D activities. This was the achievement during his tenure as a research engineer at CFTRI. Then once he got as a scientist, the career as a scientist in CFTRI, so he underwent so many R&D projects on grain processing and engineering. Then he was into the teaching also, then project management, technology transfer, and business development activities. And he was interacting with the industry leaders and funding agencies for some of his facets of the work. So presently, he is working as a nodal officer in setting up the Global Center of Excellence in Rice Processing at the CFTRI. So his some more important features like the technologies wherein he is involved in the development of technologies. Around 30 of the technologies what he has developed has all been commercialized, and he has handled more than 60 of the projects. He has published 40 plus articles, research articles in reputed journals. So he has formed or he has bought out his works in the form of technical books. Around 8 technical books he has authored. Then he has 7 patents, both in the national and international levels. And he is also involved in the academic activities like guiding the projects for engineering students and as well as MTech students. He has guided more than 40 projects to the students. So since he is involved actively in academics, research, and also the industry, we have very good resource person with us to share his knowledge and experiences. So I request all the participants to make use of his experiences and try to extract the knowledge what he has gained, and it may trigger you at some point to have some research activities of your interest. So with this introduction, I welcome Srinivas sir. So I welcome all the participants and delegates from various institutes, industries, and research institutes. So I hope all of you will enjoy this session. Over to Srinivas sir.
Thank you, Professor Hemant, for the kind words and introduction. And first of all, my question is whether I'm audible, whether I'm clear over the. Okay.
Yes, sir.
Fine.
Yes, sir. Yes, sir. It's
Okay.
clear. You're audible, sir.
Thank you so much. And thanks to NIEIT for having me over. And you've had a very interesting set of lectures that I have just gone through the brochure, and I saw that there are quite a few people who have been in the industry. And I don't know if they are also online today. Otherwise, would have had some very meaningful, discussion with the people. But as I understand, there are more of people from the industry and a less number of students are there, isn't it, sir? Okay. Can I go back to my presentation? Now is my presentation now visible? Can somebody respond, please?
Yes, sir. It's visible, sir.
It's visible. Okay. Okay. Fine. So this is an area which I don't think 1.5 hours would do justice. It's quite tough to cover the entire thing. I'm still learning. It's been a learning journey, and it's always a learning journey here at this institute. And this area is also such, and it touches us each and every day of our life. So grain, who doesn't eat grains? So we all of us eat food. So that's a very important thing for us. Just to give an idea about what CSIR is, there are about 38 laboratories in the country, and all of them are headed by the Honorable Prime Minister of the country. So he is the president, and the vice president would be Dr. Harshvardhan. So he's the cabinet minister, Minister of State Sri Chaudhary, and under him would be the Director General of CSIR for all the laboratories. He is Dr. Shekhar C. Mande. And out of the 38 laboratories, one is CFTRI. At present, we have Sri Jitendra Jadhav. And in CFTRI, we have the Management Council, Research Council, R&D department, support departments, and administration. So this is the organization chart. So if you just ask me what are the other laboratories of CSIR, you would see there is the CMERI, Central Mechanical Engineering Research Institute, which is there in Durgapur. And we have an Electronic Research Institute at Pilani, a very famous National Aerospace at Bangalore. And this may interest some of you. This is Center for Mathematical Modeling and Computer Simulation. We have one of the best supercomputers here at Bangalore. Structural Engineering Research Center, National Environmental Engineering Research Institute, Central Scientific Instrument Organization, Electrochemical Research Institute, Building Research Institute, Indian Institute of Petroleum, National Institute of Oceanography, Central Institute for Mining and Fuel Research, Central Glass and Ceramic Research Institute, Indian Institute of Chemical Technology. Oh, I'm sorry, this has been repeated, and Road Research Institute. So this is just a gist of all the 38 laboratories. So you can think how vast the area is that we cover under CSIR. So if you see CFTRI and what work we have done, this is our assembly hall. This is where all our functions take place. How I wish all of you could have been seated here. We would have had a wonderful presentation here at this avenue. Anyway, God willing, it will happen in the near future. So way back in 1950, we look into community nutrition, protein, energy malnutrition, preventing post-harvest losses. So this was our focus. And in 60s, we came out with our very famous Abul, which is manufacture of milk powder from buffalo milk, which was done for the first time in the world. Then we also concentrated on supplementary foods and oleoresins and oils. And we also set up our training for food science and technology. We have a flagship project. Flagship course. I will talk about that a little later. And then in 70s, we came out with the convenience foods and then technology for rural areas, food safety and quality, and food protectants. And then 80s, we came out with the spirulina technology. That's a blue green algae, and technology for export of fruits when it goes through the ship. So how do you say safeguard them? So 90s, we started mechanization of traditional food machinery, and we also set up the state-of-the-art pilot plant. Then when we came to 2000, we concentrated more on nutrition, nutraceuticals and functional foods, eco-friendly technologies and food biotechnology. So this was our area of focus. 2010 onwards, we started working on superfoods, specialty oils, food for targeted population, nutrigenomics, food security, sports nutrition, and food for young children as well as old children. Right. So this has been an area of focus. This is our journey at CFTRI. So if you come to CFTRI, you will have so many departments. There are about 18 departments which would concentrate on R&D and support departments. Among these departments, under the vertical of technology development, so I come from the Department of Green Science and Technology. A question that would be asked is, what is an engineer doing at Green Science and Technology? So I'll answer that. So I was talking about this MSc Food Technology course, one of its kind course in the country. There are only 30 seats all India. We have an international school of building technology. Only 24 seats are there. And as Professor Hemant was mentioning, I'm going to set up this global center for rice technology, which is coming up shortly. And we also do a lot of short-term training courses. We have PhD programs from other universities and ACSR. Even engineers can do their PhD here. Project thesis and dissertation, you can do it here. We also recruit project assistants for our project work. So this is what I was telling. So you can do your final year project work at CFTRI. So either BE or BTech or ME or MTech, you can do your project work. So you visit our website for more details on that. Right? And our technologies come in so many areas. It should be cereals, bakery, beverage, convenience foods, machinery design, fruits and vegetables, meat and marine, microbiology, plantation products, protein specialties. So for those entrepreneurs who want some technologies, there are some technologies just is available on our website, which is totally free of cost. There are 15 of them. So you can just download the technology and make use of it. You don't have to pay us anything. So that would be helpful for you. You can just go through our website for that. So, in other words, you can say that our institute is a multi-specialty food hospital. So, anything and everything to do about food is what we do here. Now, we always talk about innovation. What is innovation? So, if you ask Google uncle or Google auntie, as the case may be, depending on your choice, so you would get so many definitions. I will not go through these definitions. You would say that it would be creating more effective products, processes, service, or technologies idea that are available to the market and government and society. If you ask me, the most interesting innovation has been in the area of a bottle, right? So there are so many different types of bottles. So this bottle has got a built-in handle here, so that it is easy for you to hold it and then pour the engine oil into your motorbike. Now this one saves a lot of space. And when I go on a tour, I would prefer this sort of a thing. So there will be 3 different types of drinks depending on my family needs. And today you have bottles which have got storage space for your keys and other things, right? And even you can also look at this bottle wherein there is a charger for your mobile. So our mobile has become um, a part of our life. So even the water bottle has modified itself to accommodate a mobile and give you a charger. And this is an eco-friendly bottle which is made out of paper. So your environmental concerns are addressed. And if you're a sports guy, you need to spray some water onto your face when you're working out. Yes, there is a bottle for it. And there's a bottle with a bottle opener at the bottom. So I think people who are like me, who are beer drinkers, always find it a difficulty in opening the bottle. So this is there at the bottom of the bottle. So this is how you can think of innovation, right? Then if I look at bottles according to age, Now, the first bottle that you would touch when you're 0 to 5 years old is this bottle. Then 10 to 15 years old, you would have this bottle. I don't know if it is available in the country even today. I hope so. And the next bottle that we would see is, oh yeah, a Pepsi, man. Okay. Now, we also graduate, and the bottles also have graduated. So you have this bottle next, right? So when you're 22 to 65, and after 65, yeah, you would have this bottle. So what I mean to say is, if you take for technology, you should first decide what is the age group to which you are going to target your food. So it is not something that you would have which is applicable across all the age groups. So first we should find out what age group are we addressing this product for, and then based on that you will have to uh, take up the process of finding out what food you're going to develop. If I look at engineering, then yeah, we had discrete, you know, um, departments: mechanical, electrical, electronics, computer science, etc., etc. Civil, I'm sorry, I forgot that. So today, if you look at it, so it's not just pure mechanical engineering alone. So you would have electronics built into it, computer science built into it, everything. So a mechanical engineer has to look into all areas. It's not just one area. So what is new? There are so many things that are new. In fact, if I go back to my college days, 2D was the in thing then, but today 3D is the in thing. And nanotechnology, biotechnology, robots, intelligent sensors, microprocessors, alternate power sources, etc., etc., etc. The list keeps going on, right? So, what was a dream then is a reality today. So you have sensors that monitors the patient's conditions real time, driverless cars, intelligent refrigerators, projection on spectacles, like you see here, the virtual keyboard, right? Interactive tables. The entire table surface has become the projection, gesture TVs, and so on. So, I don't know. Everywhere you have technology that's coming in, which is affecting our life. The question would be, what is an engineer doing in grain processing? Is he a misfit? So, what should I study? What should I refer? What book should I refer? What is his role? And how to excel in this area? I'll answer these questions. Is he a misfit? No, of course not. An engineer is required in all areas of life. What to study? Core subjects. So keep your basics intact, and have your core subjects that have to be studied. What to refer? I'm sorry, there are no ready-made solutions. So only based on your basics and core subjects can you apply it to grain processing. What's his role? Multidisciplinary. I should know my biology, I should know my chemistry, I should know my physics, I should know what is food, I should understand what happens when the food goes inside the stomach, and everything has to be known before we can embark upon this area. How to excel? That's what I said. Keep your basics intact in any sphere of your life. So what does he do? He does machine and process design and drawings. The scientist will say, remove the husk of the grain, don't damage the bran. So how to do it? It's the engineer's cup of tea. So I also had to find out the economics of the process. Just not enough if I can just find out what a process can be, how it has to be designed, etc. I should know the economics of the process. I have to interact with the customers, the industry people, the equipment vendors, and then see if these two can match. I have to set up the plant, take trial productions, and troubleshooting is usually done on site. And then I have to train manpower on the machine usage, and also to train the students, etc., etc., etc. So it is not just one particular defined role. Each day is different. Each day it is a new idea that is coming up, right? So all my photographs here are copyright of respective sources, so I should thank them for that. So when I talk about grain processing, there are so many grains. The list is quite huge. Each grain is different in its own way. It is consumed differently. So each grain has to be processed differently. So for example, if you take paddy, from paddy you can make so many products. I can make rice, I can make flakes, I can make dosa, I can make chutney. So processing is different. I can make expanded rice puri, right? So the processing machines differ from grain to grain and on the end product. However, amongst the grains, there are some similarities which exist. Okay. So if you can see, for example, this is paddy, the structure is different. Wheat, structure is different. Maize totally different. Jowar different. Barley different. Size and shape varies. The anatomical parts also vary. Even for example, millets or pulses. So here you have dicotyledons. This is a monocotyledon, right? So all these are monocotyledons. So the structure, the shape, the size, and its composition are different. And grain processing means different things to different grains and different people. Now, if I am a farmer, I look at the grain differently. If I am a food technologist, I look at the grain differently. If I am an end consumer, I look at the grain differently. And if I'm a medical, person, I look at the grain differently, right? So I have to address all these requirements. So that is what it is all about. So let us come to our department of grain science and technology. So we have developed so many technologies here. So, parboiling methods and curing of paddy, detection of basmati adulteration, right? And then you must have seen if you have eaten this mouth freshener, Pas or Bombay. So there is one dal there. It is nothing but your coriander dal, right? So coriander is a dicotyledon, and that is put into the supari. Flaking systems today, you have rice, jowar, maize, millets, oats, pulses, anything. You name the grain, I'll convert it into flakes. So we also have enteral food formulations. These are food given to people who cannot eat through their mouth. So they are medical patients. For them, you have to feed it through their nose or make a hole in the throat and then feed it through there. So such formulations we do for infants, halwa, and we also have diabetic rice. That doesn't mean that the rice has got diabetics, but it means that even a diabetic patient can eat this rice. Now, if you know how to make ragi mudde, you know how difficult it is. Here we have a technology wherein you take this flour, add water to it, make it into a mudde, keep it in a steam cooker, idli cooker, steam it, your mudde is ready. So this is what we do. So I was talking about the instant traditional foods that we developed in 70s. If I read this, I will be sounding like a hotel waiter. ಏನಪ್ಪ ಇದೆ ತಿಂಡಿಗೆ ಇಡ್ಲಿ ವಡಾ ದೋಸೆ ಜಾಮೂನ್ ಜಿಲೇಬಿ ಚಟ್ಲಿ ಮುಚ್ಚೋರೆ ರಸಂ ಸಾಂಬಾರ್ ಇದೆಲ್ಲ ಹೇಳ್ತಾ ಬಂದ್ರೆ then you will know that I'm just a hotel waiter. So all these things were developed way back in the 70s. Now I would like to just call your attention to, for example, this orange peel curry. We eat the orange but throw the peel, we can also make a curry from it, right? So these are the things that you can think of. Okay, machinery. There are so many machineries that we have developed. This is for modernizing the huller. So simple rice milling systems, parboiling plant, flaking system, dal milling systems, and then a puppet press. This is a free technology on our website. So even before you make the milling, you can detect the crack in the paddy, and you can see if it is already broken, then it means that it is going to break subsequently, and that paddy is not to be taken for raw milling. 1 ton per hour maize milling plant, millet milling plant, a tiny rice mill. This consumes a power of just half HP, which is less than our domestic mixie. So in our in our homes, we can mill paddy and convert it into rice fresh then and there to the degree of polish that you desire. Okay. So this is our founder director, Dr. V. Subramaniam, who set up a synthetic rice plant. Now this work was done way back in 1950-52. So he converted tapioca starch into rice. So that was his visionary. And then this is how the women there were grading the rice manually, the synthetic rice that they had prepared. You have pulse-based soup. This looks like tomato soup, but it is actually made from horse gram. This is a mini dal mill. It's a machine used for milling of pulses. And this is jowar flakes. You can see how good it is, right? And this is a vermicelli that is made from millets. So today you can give any grain, we'll convert it into vermicelli, right? So let's look at some innovations in grain processing. So it is a very ancient technology in India. So I would like some of the students to switch on the microphone now and answer the question that I'm going to ask. In our scriptures, in our olden day stories, there's been a story of somebody who came and met Lord Krishna, right? Who was this gentleman? Sudama, right? What did he give Krishna?
Puffed rice.
Not puffed rice.
Flat rice.
Flaked rice, yes. So, the story of Krishna is about 5,200 years old. So, Sudama or Kuchela, he gave rice flakes to Lord Krishna. So, way back 5,200 years ago, we knew how to make flaked rice from paddy. And what the hell are we doing today? We are coming back the whole circle. Let's come back to there only, right? So, what has been mentioned, I don't call them in our mythology. It is not a myth. It is truth. So it is not mythology, it is scriptures. So there are a lot of things that have been told in scriptures which have a scientific background and proven today, right? So the concept of eating whole grains was mentioned in Vedas, right? So they mentioned the type of food to be eaten from the womb to the tomb and beyond. So even after a person dies, what is the sort of food to be given to them? They classified these foods. So they were called cereals or shukadanya or pulses or shavidanya, Phal as fruits, Shakam as vegetables, Payovarg, which were milk products, Madhyavarg, alcoholic beverages. So even then they had these things, and Mansavarg, which were animal products. So classification of food and food in our lifestyle has been there in our culture for quite some time. So if you see CFTRI, what would be our technology? It would be a process or a product or a machinery. We do consultancy, we do detailed project report, which is bank ready. We also give advisory assistance. Okay, so this is about the history. So if I talk about the work that we have done at the department, we did this hot soaking method of parboiling way back in 60s, which was given to the world free of cost. So everywhere it is mentioned as CFTRI's hot soaking method for the first time in the world, right? Curing of paddy, it is to convert new paddy into old paddy. So new paddy, when you convert it into rice and cook it, it becomes a lumpy mass, which we don't like to eat. So it has to be made discrete grains after cooking. So that is done by aging. So aging you do by keeping it in a godown for about 1 year. Instead, we can do this aging, artificial aging, just within 1 day. So this was done in way back in 60s and 70s. So I mentioned about this early 50s. Subramania worked on producing rice from tapioca starch, right? Ready mixes in 70s and 80s. Okay. Pressure type destoner, which is a very common machine everywhere in the country today. We did it in 1970s. Mini dal mill, we developed in the 80s and gave it to people free of cost for augmenting the farmer's income. So whatever we are talking about doubling the farmer's income today was already done by us way back in 80s. So we made what is known as an energy food formulation in collaboration with protein chemistry department. It was given to all schools. So that concept was there. And I was behind this work of developing the 1 TPH maize dry milling system using indigenous machinery. So no imported machinery, all 100% indigenous machinery. So I converted a rice mill into a maize mill for which I hold a patent, right? So many in-house projects that you have taken from 2000 onwards. Again, a question for all of you. All the participants are from Karnataka or even outside Karnataka?
From various regions.
Can somebody respond, please?
It's other India.
All over India. Okay, fine. Then all of you have eaten rice. Okay.
Yes, sir.
If I take, okay, all India, how many rice varieties are there in India?
Don't know, sir.
Exactly. In 1970, there were about 110,000 varieties of rice. Not one, not two, but 110,000 varieties of rice. Okay. If I take Karnataka alone, there are about 100 or 115 rice varieties in Karnataka alone, right? So we grow about 125 to 130 million tons of rice or paddy every year. Not a small amount. 125 million tons. Right? Keep this in mind. So if I take Karnataka alone, you can see, 102 varieties of paddy. Now each paddy is different in its composition. Therefore, they have been developed. For example, there is this variety known as Swarna, which is very good for diabetic patients. So, like that, each one is different, but the processing machine for all these varieties is the same, which is in fact a very sad part. I'll come to that later. Okay, so I'll go through some case studies with respect to your paddy itself. If I take paddy, there is this husk, outer layer called husk. It has got two parts, lemma and talia. Now, this is highly abrasive in nature because it contains 99% silica. In fact, it is so abrasive that they use a stream of air containing paddy husk and they machine engine bores. So, your honing that you do in mechanical engineering, right? Reaming and honing or drilling. After drilling a hole, you do a honing. Instead of honing, they use paddy husk. Now, bran is the most important part of it, and which contains a lot of nutrition. And unfortunately, what we do when we go to the market, we buy a rice which has no bran in it and therefore has no nutrition. Germ is the portion which is the embryo of the grain, which is here, and this will germinate into a plant, right? And the endosperm portion, this portion is what we eat. So now you have to mill this. Now, what are the engineering properties of these grains? So you need to know the length, the breadth, and the thickness, right? I need to know the dimensions. From these dimensions, I can derive the shape, I can derive the volume, I can derive the surface area. And therefore, that will tell me how many grains of paddy will sit in 1 cubic meter. I have to also find out the 1000 grain weight. Okay. So if I see the 1000 grain weight, that will give me an idea of how many grains are going to be processed, right, at any given point of time. Now you look at maize, it has 400% variation in its 1000 grain weight. Now look at the problem that I have to face. When I design a machine, when I see a variation of 400%, where is my factor of safety? Gone. So I need to know the density, I need to know the bulk density and the true density, and with that I will find out the porosity. I need to know the frictional properties. I need to know the aerodynamic properties. I need to know the thermal properties, for example, specific heat, thermal conductivity, thermal diffusivity of a grain. I'm not talking of metal or plastic, of each grain. I need to know that. And I also need to know the calorific value. For example, if I take husk, it has a calorific value of 3500 to 3900 kilocalories per kg. What does it mean? It means that 2.5 kg of rice husk is equal to the calorific value of 1 liter of petrol. So if I can burn husk effectively, I am generating power. So I can look at this as a source of renewable energy each day, every day. I need to know the optical properties. I need to know the textural properties. How hard is the grain? Does it bend during different moisture contents? What happens to it when I press it? How will it behave? All these things I need to know before I can design a machinery or before I can do any other work. Now, if you ask me, if I have to find out the length, breadth, and thickness of a grain known as ragi, how do you do it? This is a problem that I'm posing to the academic community. I need to know the length, breadth, and thickness of ragi. I can use a digital vernier calipers, but I cannot hold the grain. Now, can I find out some other method of doing it? This is where your academics can help us. So, if you can come out with a method where I can measure the grains or dimensions without having to touch it, all the 3 dimensions I need. Food for thought for you, right? So I told you the volume, for example, for a maize grain, the formula is given. When I know the length, breadth, and thickness, I find out what is known as the geometric mean diameter, which is cube root of LBT. The sphericity index, it will be cube root of LBT by L. Arithmetic diameter, L plus B plus T by divided by 3. Surface area for paddy is by this formula. Aspect ratio is B by L. I need to find out all these things before I can design a machine, right? So frictional properties, I need to know the frictional properties, how it will be behaving. So this is helpful in the design of hoppers, chutes, dryers, storage bins. So if I say angle of repose, it is the angle between when I pour some grain onto a flat surface, it forms a heap. So the slope of that cone with the horizontal surface is the angle of repose. For example, for rice, it is 37.5 degrees. So any pipe that has to convey from one place to another has to have an angle with the horizontal, which is more than the angle of repose, right? That I need to know. And what is the static coefficient of friction of the grain with respect to the surface? So whether it is on plastic, whether it is on metal, if it is metal, which metal? Whether it is MS or SS, if SS, which grade of SS? Stainless steel. SS 306, 316, 316L, 3.4, I need to know that. So we need to determine these things, right? So aerodynamic properties, because some places what we do is we carry the grains through air or water. So I need to know the terminal velocity. So what is terminal velocity? It is the velocity at which the grain remains suspended in a vertical pipe. So I put the grain here, I start increasing the speed of this blower, therefore the air passes through this, and then when it comes here, the air is trying to lift the grain. So it should be suspended. If I take paddy husk, the terminal velocity is something like 1.5 to 2.2 meters per second. I also need to know the drag coefficient. So you are talking of lift and drag only in your turbo machines and things like that? No, sorry. I'm welcoming you to my world. I need to know the drag coefficient of grains also, right? So I need to know the projected area, the air density, the terminal velocity, the mass of the grain, and acceleration due to gravity, from which I can find out the drag coefficient. So this is how we make use of these things. Now, can I have an instrument to do this? This is what the academics and the industry can look into. Collaborate with us, we can do something in this area. Coming to automation, so again, Google Auntie will give me all these things. So what is automation? To perform work without the aid of people. So that is the new thing. I'll not go into these details, right? Mechanical engineering is energy in motion. So when I take grains for flaking, what do? I take grains, I soak them in water, hot water, and I roast it. I roast it in sand, for example, because sand has a very high thermal conductivity. Then I process it to remove the layers. I flake it, means I press it between two steel rolls. I dry it. I sift it to remove the brokens and get the head flakes or big flakes. Now, if you take this continuous rice flaking process, so this is the process I told you about. I soak it in hot water, drain excess water, roast in sand, dehusk it, means remove the husk, polish it, and flake it. So the continuous roaster is used for the roasting process. So here it consists of two concentric drums. Outer drum has sand, which is heated from below. Inner drum has wet paddy. And therefore, sand and wet paddy get mixed. So heat and mass transfer takes place. Some of the professors may be wondering, heat and mass transfer in grains? Yes, sir, it is very much there. So we need to know all these properties here. So the sand picks up moisture, and at the exit of the roaster, it is sent back, and it is sent back to the outer drum for heating, and the paddy which has been processed is taken for further processing. So this is partially boiled or parboiled, right? So this hot paddy is dehusked in a centrifugal sheller. This is the only sheller which can dehusk paddy in the hot condition. What is the temperature here? The grain temperature is above 95 degrees Celsius, right? This is the only machine that can work on it. So what does it have? It has a circular disc. Oops, sorry, I'm having a problem with this mouse. So a circular disc with veins in them, right? Now, what is the angle of the veins? To see that I can have maximum exit velocity. A nice design problem, right? All my colleagues in the academy can think about this, right? So brown rice is polished to the required degree, and then rice is flaked in one shot into thin flakes, that is 0.4 millimeter thickness. Now the funny part is, when I do this, the processed rice falls between two hardened steel rolls rotating in opposite directions. One roll is fixed, the other roll moves laterally, therefore adjusting the gap, and they are pressed using disc springs or Belleville springs. So this is how the disc spring looks like, right? Why do we use disc springs? Because it saves a lot of space. So single pass rice are flakes, but look at this. The flakes have a bounce back property. So if I press it to 0.4 mm and I leave it, it bounces back to 0.5 mm. So if I want 0.4 mm, I have to press it to 0.3 or 0.35 millimeters. Then only it will come to 0.4. So we need to know the property of the grain before I can design this machine, right? So for each rice grain, it requires 100 kg force to be pressed into flakes. Now imagine a system that I'm designing for 300 to 400 kg per hour, right? Okay, so each grain weighs about 0.02 grams. Each grain weighs 0.02 grams. The thickness of each grain is 1.2 mm. Now, for a roll length of 600 millimeters, the force that is coming on the roll is something close to 45 to 50 tons. Right? I'll talk about that a little later. So this is what I was talking about roasting. So this is the drum which is rotating. The material is fed by a vibratory feeder, soak material driven by a motor and a gear here. Roasted material comes out, there is a source of heat that is given. Okay. What we did with automation, we changed the vibratory feeder into a screw feeder, right? So this is a screw conveyor. I feed the material, it keeps coming here, and this is going into the roaster. And the roaster is being heated from the bottom. Now at the exit, when the grains are falling out before the sand is removed, I am measuring the temperature using a thermocouple, chromonaluminium thermocouple. Now this temperature is taken to a PLC PID controller. I hope you know what is PLC PID controller. Programmable logic control and proportional integral derivative. This controller will take the input of temperature, and whatever temperature that I have set on this system, it will maintain that temperature by talking to this motor here. This motor will drive the roaster. Now, if the speed of this roaster increases, then what happens? The time into which the grains remain here is going to reduce. So the residence time varies here. So if I reduce the speed, the residence time increases. And this fellow also talks with the screw feeder. Now, depending on the temperature, if the temperature has become high, then it means that it is one is the control of speed and also the control of feed I have to look into. So then what it does is it will say, "Arey baba, temperature zyada ho gaya, so you feed more material," right? So this is the automation that we did. So for a non-automated system, we did those changes and put up the whole thing here. So this was a project that was funded by DST, Department of Science and Technology, and we have one such system working in our institute. So this is how we can do automation of an existing non-automatic system. I think this is the solution that we should be looking at. Whatever is non-automatic, can we make it automated? Can we involve a lot of electronics and sensors into it? So this is the flaker I was talking about. So there's a vibratory feeder, there's a screw rod which controls the gap between the two rolls. These rolls are rotating in opposite direction. One is fixed, the other is movable, right? So this is an flaker which does not have any automation, right? So what we did, we put a DC motor, we put a computer, right? It will talk to the DC motor, and this DC motor is coupled to the screw rod, and therefore it will adjust the gap between the rolls. Now, how to know what is the gap? We use what are known as LVDT sensors, linearly variable differential transformer sensors. So they were put onto the elements of this roll to see the gap between the rolls, and the gap was displayed on the computer, right? So a non-automatic system was automated using available components. So this is one another work that has been done at our institute. So this is just an example to give how we can go about making use of our basics to see that we can bring about automation. So I was talking about this. So each grain is 100 kg force. So when I did this work, now you can see that the load here is a UDL along with impact. So here what we do is classic design says you have to design for stress and check whether the stresses are within limits, right? But here, since I don't want the roll to deform, I design it for strain. So therefore, I make use of Castigliano's strain energy theorem, right? So the moisture content of rice is high, therefore these roll metallurgy has to be different. So I had to look into the metallurgy also. And what happens is when the two rolls, when they touch each other, under the force, the rolls become hollow. So that means that at the edges, the gap is less, and here the gap is less, and at the center, the gap is more. So how do you overcome this? I gave a reverse camber. So it will be radiused in the reverse direction. Under force, they become parallel. So this is how we can make use of. So this work when we did, there were no computers and no ANSYS software. Today, everything you do, you go put it to ANSYS or HyperWorks or SolidWorks or whatever. But those days, it was not there. And simple calculator. Let's come to rice milling. Rice milling means you take paddy, clean it, remove the husk. That is the husk here. And then all paddy is not converted into rice in one shot. So there is a separation of paddy that is left over here. And then it goes back for de-husking. And then you polish it or whiten it to take out the bran. And then you grade it to get the rice. So this is in a nutshell what is the rice milling technology. So when I come to the rubber roll chiller, so there are two rubber rolls rotating in opposite direction and they're spring loaded. So when paddy comes here, because one roll is rotating fast, another roll is rotating slow. So there is a difference in the linear speed, right? So the gap has to be half the thickness of paddy, right? So I'll tell you that. So they rotate in opposite directions. The difference in the linear speeds, not the RPM, linear speeds has to be 2 meters per second. Only then there can be shear. So how do you get compression? The gap between the rolls is equal to half the thickness of paddy. So the gap here is equal to half the thickness of paddy. The hardness of rubber, for metal we know it is either Vickers or Brinell or Rockwell, but for rubber it is Shore. In Shore there are many grades A, B, C, D. So the hardness of rubber should be 85 to 90, Shore A hardness, right? So since there is a lot of friction taking place, there is a lot of heat generation. When there is heat generation, the rubber becomes soft and the wear and tear increases. Therefore, the rolls have to be cooled. And the life of the rubber roll varies from the date of manufacture. So if it has been manufactured on 1st of January 2020, I should not use it until March. Between March and September, I use it, the life of the rolls is maximum. After September, if I use it, then the life again comes down. So this is a feature that has been noticed in rubber. So the rolls have to be interchanged every 8 hours because the diameter of the rolls changes, right? When the diameter of the roll changes, the linear speed is going to change. So V1 minus V2 at some point of time, because of the change in diameter, V1 minus V2 tends to 0, right? If it tends to 0, then what happens is just a press, but there is no shear. So therefore, every 8 hours, we have to interchange the rolls to see that the linear speed difference is maintained, right? And paddy husk is highly abrasive, contains 99% silica, and therefore the rolls wear out very fast. Okay. So what we did, automation for this. So we used a light source. There's a light source on top. I cannot put it to the center because there is paddy and rice coming out here. So the light that is coming falls on the roll and it is coming onto a sensor. So the shadow length from here, this portion is the shadow length. This portion is shadow length. So therefore there is no electricity or voltage developed by this sensor. Then this is the area. that has been exposed to the light. As the roll diameter decreases, the area of the sensor exposed to light increases, and therefore that is taken to a computer with a dedicated software, and then we connected this to a Evans 4-bar straight line mechanism with stepper motor. Now this is a straight line mechanism to move these rolls in a straight line. Okay, so then the stepper motor is given a command by this computer depending on the wear and tear that this has to move forward, and then this computer also talks to each of these motors. This has one motor, this has another motor. So this computer talks to both of these things, and then after every 8 hours, it automatically interchanges the speeds of the rolls. It doesn't interchange the roll per se, but the speeds of the rolls are changed depending on the amount of time that has passed by. So this is an automation that we did, and what we did was not infringing on anybody else's patent. So we found that others had put a wear plate, right? And then some people had looked into the load current of the motors. So we did this as another DST pro-funded project, right? So if I look at paddy separation, separation of paddy and rice is based on the density, size, surface roughness, and bouncing properties, right? So today automation has come in such a way that the machine is able to take care of itself, because of the sensors that have been put into it. Now let's talk about a tray separator. Here, when the separation takes place, paddy comes here, rice comes here. So the sensors will see where this band is moving. There will be a band here. This is the input point, and this is the exit point for paddy. This is the exit point for rice. So then what here this is rice and this is paddy. So electronic eye assembly will take over, servo motor controls will take over, and it will see that the operation and maintenance of this machine, maintenance with respect to the separation of this machine, is taken care of by your sensors. So that has been the technology today. When I come to polishing, polishing is very important because we need to remove the layers of bran. So it is highly energy intensive, right? So if I go to the principles of polishing, either it is abrasive or it is friction. In abrasive, there are two types of polishers, horizontal or vertical. So polishing of rice is never done in a single stage because you need the kernel to be intact. It should not be broken. So it is always multi-stage polishing, not single stage, right? So if you see the energy that is consumed, 85 to 90% of the energy is consumed by the polishing process. Now, can we reduce this? I don't think so, right? So what are the types of polishers? Look at this. Cone polisher, horizontal polisher, vertical polisher, verticone polisher, friction polisher. The which polisher to use for which variety of rice? Nobody has done a study. So if some of the academic people are interested, I think we can undertake it. We have all the machines here with us, right? Now the vertical polisher here that is available in the market today has a sensor which will look at the color of the rice, okay, and based on the set color of the rice that has been inputted by the person, it will talk to the system here wherein there is a weight, counterweight that has been given here. It will move the weight either forward or backward, therefore controlling the amount of pressure inside this chamber, and therefore that controls the amount of polish that is happening. So you would get all the grains having equal amount of polish with the least amount of brokers. Color sorting has come of age today. So each rice grain that comes here, and there are two cameras here, one here and one here. So on both the sides of the rice grain, the camera sees the grain, and then it will talk to its control unit and find out whether it is according to the set standard or not, or on one rice grain, is there a black dot? Even if there is one single black dot, it will be rejected. So there is a jet of air which will blow away the grains which are not conforming to the standards, right? So discolored grains are blown out. What is the capacity of this? Something like just 12 tons per hour. Starts from 6, goes up to 12 tons per hour or even more, right? So if you see the rice mill, This is how it used to look then, way back in 60s, and today this is how it looks like. Ultra modern rice mills. What is so special? They are all computerized. They give you the data on the yield, operating condition, degree of polish, sales details, operating cost, profit, and such mills are working in India. And these mills are Bluetooth enabled. You thought Bluetooth is only for us. It is also there for rice mills, right? So such is the level of automation that has come into the country. Now, the biggest rice mill in the country is 120 tons per hour. That is 2 tons per minute. In every minute, 2 tons of paddy is processed and converted into rice. So this is how the rice mill looks like. These are all polishers. 1, 2, 3, 4, 5, 6, 7, 8 polishers. Right? So this is the control system from where you can control the entire rice mill. Just one person is enough to look into it. Everything is controlled by this one particular system. So this is how complex the systems have become in our country. Right? There are 2 mills of 120 tons per hour in our country. One in UP, one in Punjab. Right? If you look at parboiling, there's one company which has done fantastic work in parboiling. They have become the leader in the parboiling domain. They're known as Agri Process Innovation Technology, which is there in Bangalore. So they have moved towards data-driven technologies. Right? Their system is data-driven technologies, and they have what is known as a recipe-based process. So I take the same rice based on the recipe, whether I want to do biryani, whether I want to do fried rice, or whether I want to have it as table rice to eat with sambar. The processing is controlled by the whole computer, right? And they have also moved into Internet of Things and online process control from multiple platforms. They've also developed an app to determine the process control even before installing the machine. So the app will tell the rice miller, it will ask questions. The questions that he answers will then decide what is the type of rice mill that has to be, or the parboiling system that has to be set up in his area. Right? Okay, let us look at some other things that we have done, not just rice. Now, this is a continuous chakli machine, right? You know how you do chakli at home. So you take it, you take the dough, you put it into a bowl, and then press it. It's an extruder, right? So when it extrudes, it comes out. So that's what we have done. So we put the dough here, right? So the extruder will push the chakli floor here. And as it comes here like this, now here is the forming unit. So this is rotating, so it will convert it into a spiral here. Okay. And after it is converted into a spiral, it is taken to this machine. Now this is a continuous frying unit. It's not batch, but continuous. So the formed chakli goes into the gap here. Now in this gap at the bottom, you have oil. And the oil is heated, which has got even, you can see there are 3 places at which we are monitoring the temperature. So the oil is heated and the temperature is maintained. And this conveyor, it moves in this direction. Okay. So it pushes the chakli inside the oil. It will always keep the chakli submerged in oil so that you don't have to reverse it. Otherwise, it will not be fried at both the places, isn't it? Both the sides. So here it is always submerged in oil. And when it comes out here, we have put this washing machine thing, which is used to dry your clothes. Similarly, here the chaklis are put into this spinner, wherein excess oil on the chakli is removed, but the chakli should not break, isn't it? And that is the most important thing. So automation is when we give a ramp up time and then we go for the maximum speed. So that feature has been built into this spinner to remove the excess oil, and then you take it out and package. Of course, packaging machines today are so fantastic. Everything is automated. Even forming the sheet into a plastic, from plastic sheet into a pouch is done on the spot, and then this material is packed in. Okay. At our institute, you can also look at what is known as an electronic nose. So whatever food we have developed, you know, it will be tested through the electronic nose, and the electronic nose will tell me whether I'm getting the flavor of basmati rice or whether I'm getting the flavor of something else, whether I'm getting the flavor of a particular food. This has got its own database, and then from the database it will come out and tell me, no, this flavor is not there, that flavor is there. So all our subjectivity is removed. So when I eat the product, I may say, hey, ನನಗೆ ಯಾಕೋ ಸರಿಗಿಲ್ಲ, it's not good for me, मेरे लिए ठीक नहीं लग रहा. But here, this entire thing is taken over by the computer. We also have an electronic tongue. So you have a lipid polymer membrane, which is the most important thing, and an aluminum chloride electrode, which also looks into the taste profile. And this system also has its database, and then it will tell you how the particular food will taste. So I can test it here objectively, right? And then get to know whether my product is good for the market or otherwise. We also have a digestive system, 100% mechanical, guys. So how does the system, the food go down our food pipe? It is a peristaltic movement, isn't it? It is compression and then rarefaction, compression, rarefaction, compression, rarefaction. The same thing is simulated here. And please remember, the stomach is not just an idle thing that will stay there. When food has come into it, the stomach moves, the stomach compresses and it bulges, and there all those things are put into this. And whatever digestive juices that come from the duodenum, the jejunum, the ileum, all those things in the regular exact quantity based on the metabolism of a person, based on the age of a person, will come into the stomach, and then after say 3 hours of time, whether the digestion has been complete or not is tested. Can I do it in a human body? I cannot. I cannot put my hand inside and take the food from my stomach. So here is an artificial stomach which will be useful for me to conduct studies. What happens if I do the study with a human being? Then we don't know what effect it is going to have on a person. When he eats so much of chakli, what will happen? We don't know. So all that can be tested here using this digestive system that can be developed. This has been developed indigenously. Okay, I almost come to the end of my slide presentation. There are some more interesting machines that I would like to share with you that we have done here at our institute. We have a continuous chapati machine which gives you 600 to 800 chapatis per hour untouched by human hand. And it is cooked on both the sides, this side and this side. Both the side it is cooked. Right? So the LPG is 3 kg per hour, only 7.5 HP. Chapati size is also fixed. So you extrude the wheat dough. When it comes out, there is a die which cuts it into the circular shape, and the excess material is recirculated. Right? 6 by 1 by 2 is the dimension of the chapati machine. Okay. Then idli machine also. So if you go to hotels and then find how the idlis are made, you have the batch type of system wherein they use a cloth. On the cloth they pour the batter, and then the whole thing is steamed. But I don't know if the cloth has been properly cleaned or otherwise, or it was used for something else. But you can always say it has been steamed. But what excels or what other dirt was there in it is not known. But here you have a automatic batter dispensing system which has been patented, and it gives you 1200 idlis per hour, untouched by human hand, with uniform shape, size, color. So this is another machine that we have developed here. Continuous dosa making machine. So you can make about 400 dosas per hour continuously. So the batter falls here, and as it falls here, this is a rotating plate which goes round. It's been heated from the bottom using LPG burners, and then there is an oil addition also. And as it comes, it is curled into this shape, right? So before it gets curled, you can put your masala here. So then it becomes masala dosa. If you don't put masala, it is plain dosa. So this machine also has been developed at this institute. But there's only one problem, boss. The typical taste of your dosa that you get in a hotel is not available. It's not possible to get it. Why? Because in that dosa making system that they use in the hotel, they use one broomstick, right? And God alone knows where that broomstick has gone. And sometimes you also have this that has been put into it, right? A lot of sweat also falls onto the tawa. So that is not there in this. It's a hygienic method of doing dosas, right? Other machines that I can talk about, a continuous vada making machine with the hole, okay? A continuous puri making machine. I mentioned about the tiny rice mill. We have also developed a garlic bulb breaking and peeling system. So not only convert the garlic into those individual cloves, but even peel the cloves, right? Automatic lemon cutting machine. In this is the mechanical version wherein one pieces gives you 8 strokes. The capacity is slightly less, maybe about 100 lemons or 150 lemons per hour. You have a pneumatic system which would do something like 500 lemons per hour, right? So you can control this. You can either have 8 pieces or 4 pieces or 2 pieces in one stroke. Continuous laddu making machine. So you don't have to use your hands to do it, right? So the laddu is made automatically. Your laddu or rava laddu, anything can be made out of this. Spherical shapes, foods. You have a continuous ragi mudde machine. People in Karnataka would know this. So this is a machine which does ragi mudde continuously. We have a continuous tabletop wet and dry grinder in one system itself. So I don't have to have a separate grinder for wet grinding and a separate grinder for dry grinding. So both of them in the same system. Continuous rice food cooker. Continuous cooker for food cooker for rice. Okay, so it can give you about 100 kg of rice every hour, right? So you put rice at one end, it gets cooked, and cooked rice is discharged at the other end. My colleagues are working on this system, continuous mission vision assisted jalebi system. So the jalebi farming has been done, but what is this machine vision doing? So what it does is there is a camera which is looking at the jalebi when they are frying in oil. So unless and until the jalebis get that desired color, the jalebis will remain in the oil. Once the color has been achieved, then it is removed from there and then soaked into your sugar syrup. Like this, I think we can start looking at so many other machines that we can think of. So you only need to open up your, mind and then see that you can do some more things. Okay, now can anybody tell me what this is? While you try to answer the question, I'll take a drink of water. Nobody? 85 people were there. I don't know how many are remaining now.
So it's a simple joke. Okay? This is maybe woolen. It will be used for summer as well as winter. It will be with respect to weather forecast.
I'm not asking the jacket. I'm asking what this is.
Kadala Mutai.
Kadala
Okay,
Mutai.
that's okay.
No, this is nothing but a coated grain. You got that? So I give a coating to any food product that you can talk about. Right? So what sort of coating? Whether you want it to be sweet, you want it to be coated with jaggery or sugar or sucrose or stevia, or you want it to be coated with masala, salt, anything. So that's how you can think of. So you have to think out of the box, right? So yeah, I think that's my presentation. Little by little, we can build a lot. I think we need a lot of these academic institutes and colleges to join hands with our research institutes like us, and we should work towards making India number one in the globe. We can do it. So, like this weaver bird that makes this beautiful nest, whoever taught it, God alone knows. So, nature has been a wonderful teacher, and I hope I have made my presentation interesting. Like this, I hope it was a gorilla when I started off, and I hope it's a beautiful girl now, right? And thank you very much for your patience and time. And I'll be glad to answer if there are any questions.
The session is open for discussion. Please pose your questions to Professor. So he'll be glad to answer your questions, as I mentioned.
Mr. Kishore is asking whether there is any internship in our organization. Yes, that is what I mentioned. There is an internship, and you can go to our website and then look into the terms and conditions.
And some more questions by chat box, sir. That
Yeah. Just going through that.
Employment like that. Is automation helping in reducing unemployment?
Automation. See, okay, there are always two sides to this: automation and employment. On one side, you may say that the number of people who are required to operate the machine have been reduced. But on the other side, we can see that the technology has taken over and the number of people to operate the machine has come down, and therefore employment opportunities are less. But I would look at it this way. Now, if I even take the example of rice, if automation is able to increase the yield of rice by even 0.5% because of automation. Now, 0.5% is per se is not a very big figure, but 0.5% of 120 million tons. It means that I can feed the whole country for 1 month, right? So that much extra rice has been generated because what is happening is the amount of land that is available for agriculture is reducing every day because population is increasing, and therefore what we are doing is we're expanding our land to construct buildings. So where is the land available for agriculture? And agriculture science can do only a certain extent of improvement in the yield of rice from a particular plant. So conservation is more important. So conservation is the step that comes in during the processing part of it. So if I can conserve material, if I can preserve material, if I can increase the yield during processing, that is the most important thing. And another thing that is happening is if you take the same case of telephones. Now, if I take a telephone, which I saw in the later part of my youth, and give it to the latest, you know, kid who is just passed out from 10th standard, he would not know how to use the telephone. You have the system wherein you have to put your finger and then dial through that, right? So we have graduated there. So similarly here, the skill levels have to improve. We cannot be in the same 1960s era and say that I'm going to do everything manually. No. So your skill levels will improve, and therefore your opportunities are going to be more. So it is not an opportunity of a person who is having a skill set in one area. Please remember that if you're students, your skill set has to be across multiple areas, right? So I would look at it that way. Right? Any other questions that you're looking at?
Sir, there are so many questions. So one Super Reddy has asked about Industry 5.0. So what methods are being employed to go for Six Sigma?
Oh wow! It is going in. That's what I was telling you about the company called as APIT in Bangalore. They are already going into Industry 5.0. That is what I want to do. I want to look into, say, for example, if I take I think Google has already done it. When you take a picture of a particular plant, Google has already identified it in its database and said that this is okay. This is your coriander plant. This is your curry leaf plant. This is your paddy plant. This is your hibiscus plant. Now, what I want to do is, this is my dream. What I want to do is, if I take a photograph of paddy, now once I take this photograph and put it into my system on the rice mill, all the parameters for the operation of the particular rice mill for this particular variety should be done. I think we are coming to that. So we are going into that area. It is going to come because now one major problem that I foresee in food is that it is controlled by the tongue. Now, your tongue is the one who decides and says whether the taste is good or not. And there are so many tongues and there are so many tastes, and each person wants a different taste, which is very difficult to come out with. But with respect to the basic aspects of the primary processing aspect of food processing, Industry 5.0 and Six Sigma methods will definitely come into picture. They have already come in. Food Safety and Standards Association of India has already come in with so many different types of specifications. Now they have included a specification for fortification of rice. So I can take rice flour and convert it into rice grains with a lot of nutrition in it. So for that also we are starting to develop standards, and the standards are being brought out by the government of India. Yes, so it is all driven by the customer and the industry.
Yeah, sir, one more question from Mamata Gowda. Wanted to know if you could tailor make the existing Ragi Mudde machine.
Come again, sir, tailor made.
Tailor make the existing Ragi Mudde machine.
What tailor making has to be done? See, it is the mudde size is fixed, right? That can be varied. And what else? In the ragi mudde, there is nothing else that has to be varied. The cooking time remains fixed because the amount of water you add to that flour is fixed, right? The amount of the amount of time required for cooking is fixed. So when it is coming out, the size can be varied. So it is only changing the aperture size.
Yeah,
that's it.
Right, sir.
So that's all that can be done.
Hi, sir. This is Mamta here. I
Yes,
wanted to know if we could make it into a smaller size. See, there are people who are not used to eating this, and the same thing, made as like marble shapes, the small ones, small marbles.
Okay, yeah, that could be done. That could be done. See, size is not at all a problem. Another thing is, whenever we do such a machine, now we look into the economics of the operation, right? Now, so if I have a ragi mudde machine which can make marble sized, which is like your button size idlis. Now, idli size, instead of having big, you can have it small, right? Now, what would be the minimum economic size? See, you're going to sell this machine to somebody, isn't it? You are not going to make the small marble sized ragi mudde and then sell the marbles, isn't it? You're selling the machine. Now, for the machine to be in operation, now what is the demand? What is the market? So, how many of these marbles have to be made and sold in a day?
Okay.
Right? So, this cannot be a stop-start operation. So, once you start it, it starts doing it continuously, isn't it? Stop-start means what happens is the initial few kg of ragi that comes would be uncooked. And at the end also, what happens is at the end, it would be overcooked. So there is some amount, say maybe 2% of wastage that is happening, right? Every start stop. So 2% wastage into the number of start stops that I do is something that I have to look into as an end user. And that decides the capacity of the machine. Size wise, not a problem. You wanted marble size or even ball bearing size also, we can do. That is not an issue.
Okay. So, but can we do the same existing machine?
Yeah, of course.
Okay. Thank you.
Yeah. Most welcome.
Sir, another question from Rishabh Shukla. Please explain about the rapid aging of the rice. How do you do it?
Okay. I will have to get into the grain itself to explain this. What happens is, now the endosperm or the grain inside consists of starch. Now, what is starch? Again, starch is a molecule which is made up of two components, amylose and amylopectin, right? Now, the way these components react over a period of time, and what happens to these components when it is allowed to age, is something that has been understood by scientists. Okay, so scientists have determined what is the change, they call it as retrogradation of starch. Retrogradation of starch has to take place. Now, for that to happen, either I keep it for 1 or 2 years in a store godown, or what I do is, in order to change the characteristics of starch, I give some steam. I give it a heat treatment. It's not a dry heat treatment, but a wet heat treatment. So because of this, what happens? The starch granules change in their structure, and therefore they become, they get the properties of old rice. So this is what we do. So how much of steam I should give, that is a technology detail which I cannot divulge here. But suffice it to say that I have to give it steam, and that steam duration and pressure are the details that we give when you take the technology from us. Supareddy has said, food processing industry is not at its best in India. Please comment. Right. That's exactly what I made a comment earlier, was that food processing is something. See, what happens is is Subareddy here? Can I have him on the mic? The mic on, please.
Yes, sir. Yes, sir.
Okay. Are you married?
Yes, sir.
You're married.
Yes, sir. Yes, sir.
Okay. Your wife's cooking is better or your mother's cooking is better? See, that is where the difference is, isn't it? So when you set up an industry, whom are you catering to? You are from which place? You are from Andhra.
Andhra Pradesh. Yes, sir.
Yes. So Andhra Pradesh rasam is different from Tamil Nadu rasam,
Yes, sir.
and which is different from Kerala rasam. You are going to manufacture rasam. Which rasam will you make?
Andhra
So what
Pradesh.
happens is, to answer your question, so each company which is setting up, their industry, they will try to see that they cater to the local market first. There is no universal formula. I cannot have a universal rasam formula, right? So for you people who are coming from Andhra Pradesh, you would like to have a lot of this red chili. For me, a red chili you show, I will start sweating here itself, even if you show it to me. So what happens is, in these industries, they are all local one, and they are at smaller capacities. But this condition is changing. Earlier, if you had to see the food processing scenario in the country, it was totally diverse, it was totally different. But now the technology is coming in, everybody is now, for example, I'll give you the example of rice mill. You cannot get one single rice variety in the market which is not color sorted. Each and every variety of rice, or each and every rice mill in the country, has a color sorter. If I were to answer this question way back, maybe 10 years ago, 10 years ago, even though the technology of color sorting had come, color sorters were not available. So it is a process of growth. Now, the major problem in the food industries, industries that I have seen, is that they will always try to find out whether there is a successful food industry working somewhere else, whatever he wants to put. If somebody else has tried it, then I will try. Right? So I will not be the first fellow to take the risk of putting up the whole plant for the first time. Is it running somewhere? When I buy a car, what do? I do a test drive. So here also, what the industry people do, they will see if it is running successfully elsewhere. When they see that that industry fellow started making a lot of money, then I will also put the same industry as competition to him, rather than being the first fellow to do it. Now, if this mindset changes, then we can definitely change the whole scenario.
Sir, but in European countries, it is at its best, sir, because food processing industry, European countries like Germany, like Canada, something like.
Your food habits are different. Your food is different. What do Europeans eat? They eat bread and bun with something stuffed in between them. What do we eat? What is the variety of food that we eat? It is so diverse. In European countries, you go, it is a burger, it is a sandwich, it is this, it is everything with respect to bread in it, isn't it? Majority of it. Rice eating is very little. So here in our country, if you go to a typical Kerala wedding and see how many side dishes that are there. In Tamil Nadu, you see how many side dishes are there for rice. If you go to Gujarat, you take that mega golden thali, you will say there are 105 or 106 types of different curries. Do Europeans eat that? No, nah. That is a major thing. So our food habits are different.
Thank you, sir. Thank you.
Yeah, most welcome.
Sir, one thing I want to discuss with you about the synthetic rice.
Yes, please.
So in 1950 we have that idea, and we were doing that synthetic rice. But a few months back, someone has posted some video regarding China is making some plastic rice and other things. So
Okay, that is a misnomer. Okay, that is a misnomer. See, synthetic rice we worked in 1950s, but then the raw material that we used was tapioca, right? So the cost of production was quite high because the machines that we had to use were imported. They were made from Bueller, that was from Switzerland. Okay, but today there are a lot of companies which are able to make these machines, and they are available at a much cheaper cost. Okay, and second thing is the economics of production is the main thing that decides on the capacity and the cost of the whole thing, right? So nowadays what they're doing is for every 100 grains of rice, 1 grain of fortified rice is used. So fortification with maybe beta carotene or vitamin B or vitamin A or zinc or folic acid, depending, or iron, depending on the particular target. So that is fortified into the rice, and then 1 grain in 100 grains is mixed and put. Okay, so that is what the Food Safety and Regulatory Authority of India has already decided, and they have come out with the specifications for these things also. Now, with respect to this plastic rice, now your WhatsApp and internet, on one side it is an advantage, on the other side it is um, a disadvantage, and it is a curse. Now suddenly somebody started putting like what Wuhan virus has come. Now cat BQ virus or something has come. Now this virus was detected and recognized 10 years ago, right? So they put that. Now what happens is the Food Regulation Authority of India, or even the customer. Uh, for example, you as a customer, when you go and buy this rice, when you bite this rice, would plastic have the same texture as that of regular rice? No, it cannot be. It can never be, right? So once you buy this and you come to know that there is plastic in it, will you buy it again? No. So that business is not a sustainable model. This is only to, somebody got a crazy idea, they put it and everybody started believing it. Now, somebody has also put up in the website, WhatsApp University, that steam inhalation will kill the virus, and they're making a lot of business out of it. Now, my question is, when you inhale steam, when it goes into your mouth and nose, the steam will definitely get the temperature of your body. So the virus will never be killed. For killing the virus, any effective virus, even in food, for any pathogen to be killed, it has to be beyond 60, 70 degrees Celsius. Now, can you inhale steam at 60, 70 degrees Celsius? Never. But still, we are people who believe WhatsApp. We don't believe science, and therefore we come up with these problems. Okay.
thank you, sir. Thank you, sir. One more
Most welcome.
question.
Yes,
A
please.
question from Vikas Gangadhar. Can a grain be developed by 3D printing technology?
Food has been done. Yes, not grain, but food has been done by 3D technology. It is still in its infancy in our country. There is an institute in Tanjavur, Indian Institute of Food Processing Technology, under the Ministry of Food Processing Industries. So there, one Dr. Anand Ramakrishnan, who is a product of CFTRI, he has gone there on deputation. He is the director of that institute. He has developed a 3D printing machine. 3D printing is possible. 3D printing of rice will be very expensive. That is why it is extrusion and then cutting to reduce the cost. But 3D printing of food has come. It has already come.
Thank you, sir.
Most
So,
welcome.
any more questions from the audience? You can switch on the mic and you can pose questions directly to the professor.
Rishabh Shukla has asked that
Yeah, sir. Why is there a need for
the need for synthetic rice? The need for synthetic rice is only to see that the nutrition content of rice is improved. So what is happening is, if you take the population who eat rice, their studies have indicated that the women in the village areas are deficient in a lot of nutrition like iron, folic acid, zinc, which is very essential for our growth and maintenance of the health. So, since rice is consumed by those people, the grain of rice is infused with these vitamins and minerals and then given to people at affordable cost. So, therefore, there is a need. In fact, a study was done by one group of scientists wherein they found that before this fortification of iodine in salt came in, they fortified the iodine and they put it on a sticker, and the sticker was given as a bindi for ladies. So when the lady puts a bindi, so the iodine enters through the skin and into the body. So these are all the ways in which they have tried to see that they can infuse nutrition into people.
Thank you, sir. Any more questions from the audience? They can quickly unmute and they can pose question to the professor directly. Yeah, Professor, I think no more questions.
Yeah, I think they're all hungry now.
You want to, any messages you want to convey through this platform? Please convey, sir.
Yeah, sure. Okay. Now, what I would like to share with this platform is somehow the colleges and industries are away from CFTRI. I have not even touched the tip of the iceberg. I've just given you a small, presentation of what we are capable of doing. So this is required very much, and I believe that the future of science and technology in India lies in the hands of students and the industry and academics people. So, academic people, I would request you to kindly come down. If you're in Mysuru, you're most welcome. You can just come down. We can have a discussion and see what are the areas in which we can join hands and work. There are a lot of areas. There are a lot of areas in which we can join hands. And for the industry, I would say that you need to, break the shell and come out and approach us for, solutions that you are looking at. We can tailor make solutions for your people. And for students, I would definitely say that the world is in your hands. It only depends on how you give shape to it. So your marks, I believe, are not the most important criteria. The way in which you are able to perform and use your basics, that's the most important thing. Keep your basics in fact intact. If I ask log 25 to base 5, you should know what the answer is. So only that will help anywhere, in any sphere. Thank you very much for this opportunity. Thank you, Dr. Kati.
Thank you, sir. So, Professor has thrown a light on about the history of CFTRI, right from CSIR. CSIR has around 38 labs all over the country, and so a lot of information has been given by the Professor Srinivas. So the way in which the CFTRI emerged right from 1950s to till date. So he has given completely the picture of CFTRI, which we were not aware completely. And then innovation, he has given very good example of the bottle, right? So it was very attractive. Bottles are made in the first slide, and in the second slide, the bottles which are made according to the ages. So that was very beautiful example
Exactly.
that
Yeah.
can be quoted for the innovation. And
Yes.
then
Exactly.
he has addressed the upcoming engineers. So how the upcoming engineers can have the knowledge, or they can climb up the knowledge ladders. So that was very beautiful things or the knowledge shared by the professor. So I thank the professor for sharing his knowledge and experiences, and even the conversion of the conventional machines into the automation. So that was very beautiful things which we can understand, and which we can also implement to convert some of the conventional things into the automation things.
Yes.
So he has shared the knowledge what he has gained from his experience of around 40 plus years in the field of research and academics, as well as in the industries. So I thank the Professor Srinivas on behalf of NIEIT and behalf of delegates and the participants.
Thank you so much. Thank you.
Thanks for joining, sir, and thanks for delivering a beautiful and wonderful lectures. And even the participants has chatted that the lecture was very beautiful and the information was
Yeah, I'm saying that. Yes, thank you.
yeah. You can go through it also, sir. So
Sure.
yeah, it's our pleasure for having such kind of resource person with us. I thank you very much, sir, and wholeheartedly we congratulate you on delivering this nice lecture, sir. Thank you, sir.
Pleasure is all mine.
So, there is an announcement for the participants. We have the another session at 2 o'clock, wherein the Akadas, Shri Akadas, Director of MSME DI, will be addressing regarding the assistance to entrepreneurs through MSME schemes. So he will be mentioning, or he will be addressing us the schemes what are available in the MSME for the entrepreneurs. Okay, for the assistance of entrepreneurs. So he will be joined by Gopinath Rao, Deputy Director, MSME DI, Bengaluru. So both will be addressing the participants regarding the schemes available in the MSME. So kindly join this session and make use of this session. I thank the participants and the delegates who has joined and actively participated in this session. So I think a few more questions will be there for Professor Srinivas sir. After this session, probably they will mail you some questions. So
I would prefer emails, please.
Yeah,
I will answer each and every email. Don't worry
thank
about
you,
that.
sir. Thank you very much.
Yes.
So I thank all the participants and the delegates who participated actively in this session, and I thank you one and all wholeheartedly. Thank you very much. Now we can.
Okay. Thank you very much, Katik. See you. Talk to you later.
Yes, sir. I will inform.